And now, a feature presentation. Oh, very well. Let's all go to the lobby. Let's all go to the lobby. Let's all go to the lobby. Get ourselves some snacks.
I'm Katie, and we were working on a telescope that can find objects in the night sky based on your latitude and longitude and the time of day and the date. So we had a big program written for this, and it was all going great until we realized that the Pel 4 didn't have enough memory to handle it, so we had to change plans at the last minute, and we put it on an Excel spreadsheet.
Oh my God, this boy is having an out-of-body experience. This is very bad for business.
You input your date, latitude, and longitude here, and then based on these orbital elements of Mars and the orbital elements of Earth, you calculate these other values. It sends them through all these coordinate rotations, and then you have to do coordinate transformations, more coordinate rotations, and then finally it spits out an altitude and azimuth in radians and degrees. So these degrees are the values that you would input into the program that's going into the Pel 4. Ideally, in a bigger project, we would have a bigger chip in the Pel 4 and it would be able to do the whole thing, because that's a lot easier for the user, and this would be a lot more user-friendly. But we don't have enough resources to do that, unfortunately. So that's the program part of our project.
And Isaac? What'd you do?
Design. I'm Isaac Williams, and I worked on the design part of the telescope. Our first idea was to make it out of cardboard, but we found that cardboard was not sturdy enough for all the weight and the ability for it to move, because as it moved, these wires got twisted up underneath it. So that design just got thrown away. So we just took a simple design and had the bottom motor, which spins this top part 180 degrees, and to get the pitch, this motor right here takes the telescope part and spins that or rotates that 180 degrees. The circuit is right here. We just built it off of what we've been using in labs, just as a main base, and that's about it.
My name's Ryan Mergenthal. I was responsible for programming. Basically,
Each motor relies on interrupt controls, and that was actually the most difficult part of the programming, as we originally tried to use 2 interrupts to run the code. But as you can see on the board over there, that was ultimately resolved with the help of one Dr. Batchelder. So the margin of error on this is actually a little bit significant, as we only had, based on the way we had to use counts based on the clock cycle. So the way this works is it rotates between a range of 0 and 180 degrees on the base, and then to cover the other 180 degrees, this thing can actually flip over. So they're both rotating between 0 and 180 degrees. But based on the way the clock is coded, there are only 48 valid integer values for use in that range. So the margin of error, as far as an astronomer is concerned, is fairly high, but it can be expanded on and made a lot more efficient.
This is our robot project. It's pretty much aimed towards the amateur astronomer who'd like to look at constellations with minimal input from them. What we've designed is we've taken the PEL 4 and connected it to 2 servo motors. Now, with input from the computer, it'll go ahead and it'll track certain constellations, and it'll go to the right degree and right azimuth and angle to find stars you're looking at. So here's a little example.
Go for it.
Wow. No.
It turned out it was his evil twin.
No.
Grace, come here. There's a sinister-looking kid I want you to see.
No.